What if I told you one hidden part inside a furnace can save lives? One tiny sensor can shut off deadly gas, and one wrong flame color can warn you something is dangerously wrong. If you're preparing for the TSSA Gas 3 exam, this is one chapter you cannot afford to miss. Today, we're breaking down gas appliances with every essential fact, numbers included, in the easiest way to remember. A gas appliance is any device that burns gas to create heat, hot water, cooking heat, drying heat, or process heat. Examples include furnaces, boilers, water heaters, stoves, dryers, fireplaces, unit heaters, and construction heaters. Gas appliances use three methods of heat transfer. First is conduction. Heat moves through direct contact. Second is convection. Heat moves through circulating air or water. Third is radiation. Heat travels in waves directly to people and objects. Remember it like this: pan equals conduction, furnace equals convection, infrared heater equals radiation. Now let's cover appliance firing methods. A direct-fired appliance allows combustion products to mix with the heated air. An indirect-fired appliance uses a heat exchanger to keep combustion gases separated from the air being heated. That's why most residential furnaces are indirect-fired. Now, efficiency. Low-efficiency appliances are older designs. Mid-efficiency appliances are improved systems. High-efficiency or condensing appliances are often 90% AFUE or higher, with some reaching 95% and above. They recover more heat from flue gases and usually produce condensate water. Now, water heaters. There are three major types. A storage tank. Water heater stores hot water inside a tank. A tankless heater heats water instantly when water flow begins. Tankless units may have inputs from approximately 180,000 British thermal units per hour up to 400,000 British thermal units per hour, depending on model and application. A booster heater raises water temperature higher, often for commercial dishwashing. Important water heater facts. Water boils at 212 degrees Fahrenheit or 100 degrees Celsius. Water expands when heated. Steam creates massive pressure. Hard water causes scale buildup. Sediment collects at the bottom of the tank. An anode rod helps reduce corrosion. Now, the safety device you must know. The T and P relief valve means temperature and pressure relief valve. Many residential water heaters use a pressure rating around 150 pounds per square inch and a temperature setting of 210 degrees Fahrenheit, though always follow manufacturer ratings. If pressure or temperature rises too high, the valve opens to protect the tank. Without it, the tank can become dangerous. Now, furnaces. A furnace heats air and moves it through ductwork. Older systems include gravity furnaces, which use natural air movement with no blower. Floor furnaces are installed in the floor. Modern systems are usually forced air furnaces using a blower motor. Main furnace parts include burners, gas valve, heat exchanger, blower motor, filter, thermostat, limit switch, pressure switch, rollout switch, and venting system. If the blower fails, overheating can happen quickly. Now, high-efficiency furnaces. These often include a secondary heat exchanger, sealed combustion, pressure switches, condensate drain, and PVC, or approved plastic venting where certified. If you see water draining from a furnace, it may be a condensing unit. Now, boilers. A boiler heats water, not air. A fire tube boiler has hot gases inside tubes and water outside the tubes. A water tube boiler has water inside tubes and combustion heat outside the tubes. Water tube boilers can handle higher pressures and faster response rates. Now, room heaters and decorative appliances. Examples include wall furnaces, baseboard heaters, gas fireplaces, gas logs, and room heaters. These create localized heat, but also create hazards such as burn risk, venting concerns, and clearance issues. Always follow listed clearances from combustibles. Now, infrared heaters. Infrared heaters heat people and objects directly instead of heating all the air first. That is why they are common in garages, warehouses, loading docks, and large open spaces. Their primary heat transfer method is radiation. Now, burners. The burner mixes gas and air and burns safely. A proper flame should be blue, stable, and well-defined. A bad flame may be yellow, lazy, lifting, floating, or sooting. Yellow flame often means incomplete combustion or poor air supply. That can lead to carbon monoxide hazards. Now, ignition systems. A standing pilot burns continuously. An intermittent pilot lights only when there is a call for heat. Direct spark ignition uses an electrical spark and no standing pilot. Hot surface ignition uses an electrically heated igniter. Many hot surface igniters warm up for approximately 10 to 30 seconds before gas is released, depending on design. Now, one of the most tested topics: flame sensors. A flame sensor proves flame exists. If no flame is detected, the gas valve shuts off. That prevents raw gas from filling the appliance. Types of flame sensors include thermocouple, thermopile, flame rod, ultraviolet sensor, and flame rectification systems. Now, thermocouples. A thermocouple is commonly used on standing pilot systems. When heated by the pilot flame, it generates a small millivolt signal that holds the gas valve open. Common readings shown in training material are: open circuit test approximately 20 to 30 millivolts. Closed circuit test approximately 10 to 20 millivolts. Minimum acceptable closed circuit reading approximately 10 millivolts. Normal dropout may occur around 2 to 4 millivolts. If the pilot goes out, voltage drops and gas shuts off. If a pilot lights but will not stay on, suspect a weak thermocouple, poor pilot flame, or faulty magnet in the gas valve. Pilot flame should generally engulf only the top 3/8 inch to 1/2 inch of the thermocouple tip. A proper pilot flame is medium intensity blue with minimal yellow tips and no soot. Now, thermopiles. A thermopile is multiple thermocouples connected together. It produces more power, often around 250 millivolts to 1000 millivolts depending on design. Enough for millivolt systems and some control circuits. Now, flame rods and flame rectification. Modern furnaces often use a flame rod. The control board applies AC voltage and the flame allows rectified current to flow back as a DC microamp signal. Typical flame signal readings vary by manufacturer, often in the microamp range, such as 1 to 10 microamps or more. If the rod is dirty, the burner may light and then shut off seconds later. A dirty flame rod causes many service calls. Now, venting. The purpose of venting is to remove combustion gases, moisture, heat, and carbon monoxide safely to the outdoors. 3 major systems are tested often. Natural draft uses buoyancy of hot gases rising through a vent or chimney. Mechanical draft uses a fan or blower. Direct vent uses a sealed combustion system with outdoor air intake and outdoor exhaust. If asked which system uses outside combustion air, think direct vent. Now, draft problems. Downdraft means wind pushes gases back down the vent. Spillage means flue gases spill into the room. Blocked vents, poor draft, oversized chimneys, undersized vents, or negative pressure buildings can all create dangerous conditions. Now, draft controls. A draft hood helps stabilize draft and protects the burner from excessive chimney pull or downdraft effects. A barometric damper regulates excessive draft but cannot increase draft beyond what the vent system can naturally provide. Now, vent materials. Type B vent is commonly used for gas appliances. Typical minimum clearance to combustibles is 1 inch or 25 millimeters. Many Type B vents are approved for flue gas temperatures up to 470 degrees Fahrenheit or 243 degrees Celsius. Type L vent is heavier duty and often used where approved. Typical minimum clearance may be 3 inches or 75 millimeters depending on listing and application. Single wall vent connector is commonly used as a connector only, not as a complete chimney system. Typical clearance to combustibles may be 6 inches or 150 millimeters unless otherwise approved by code or listing. Always verify exact code and manufacturer requirements. Now, safety controls. A high-limit switch shuts the burner off if temperature gets too high. A pressure switch proves inducer airflow and venting conditions. A rollout switch trips if flame escapes the burner area. A spill switch detects vent spillage. A fan control starts or stops the blower at proper temperatures. These controls protect both people and equipment. Now, the sequence of operation. This is critical for troubleshooting and exam questions. Step 1. Thermostat calls for heat. Step 2. Inducer or draft motor starts. Step 3. Pressure switch closes. Step 4. Ignition begins. Step 5. Gas valve opens. Step 6. Burners ignite. Step 7. Flame is proven. Step 8. Circulating blower starts after a time delay. Step 9. Thermostat is satisfied. Step 10. Gas valve closes and burners shut off. Step 11. Blower continues for cool down, then stops. Memorize that order. What heats water, not air? Boiler. What proves pilot flame on many standing pilot systems? Thermocouple. What protects a water heater from excessive temperature and pressure? T and P valve. What is the main heat transfer method of an infrared heater? Radiation. What does a yellow flame usually mean? Incomplete combustion or poor air supply? What type are most residential furnaces? Indirect fired. What is common type B vent clearance? 1 inch. What is common single wall vent clearance? 6 inches. What warm-up time is common for some hot surface igniters? 10 to 30 seconds. What is water's boiling point? 212 degrees Fahrenheit or 100 degrees Celsius. Gas appliances may look simple from the outside, but inside, every burner, sensor, switch, vent and control works together for one reason: to heat safely.